Hello friends. So in SAE generally, you'll have one type of question that is simplify. Simplify. Simplify the indices. What the question will tell you, simplify the. Let me do this question. Here, x to the power a square plus b square whole upon, look at here, x to the power minus ab whole to the power a minus b. Similarly, x to the power b square plus c square whole to the power minus bc to the power b minus c. Okay, over here also x to the power c square minus a square x to the power minus ac whole to the power, let me write here, c minus a. Okay, space is square, c minus a. You understood the pattern, x quotient to the power pattern, a square plus b square whole upon x to the power minus ab whole to the power a minus b. Again, x to the power b square plus c square upon x to the power minus bc whole to the power b minus c. Similarly, x to the power c square plus a square whole upon x to the power minus ac to the power to the whole power c minus a. Okay. Here, in this fraction, AB is only repeated everywhere. Here in product form, here in square addition of squares, and here subtraction. AB is only there. Here BC is there, and here CA is there. Okay, don't get confused. So this pattern of question is of one type. Okay. Now let us do the solution. How to do the solution for this type of question? Okay. While doing the solution, better what you start from the question only. After writing solution, you write the question and do it. Due to the lack of space, I am starting after this step. Okay. After writing the question, what we do from there, I will start it. Okay. Now look at here. Here the indices having the same base are in division form. Then what you will do? You keep the base same and subtract the power to get the result. You have to simplify the basic rules, you know it. While simplifying, what you have to do? Use the board mass rule. Do the problem which is in bracket first, and then carry out order of, and then division, multiplication, addition, subtraction. This thing, you know it. These are basic things. So here also, let us do the problem which is in bracket first. Okay. Here also, so x to the power a square plus b square upon x to the power minus ab is there. Means they have a same base and are in division form. And what I mean is keep the base same and subtract the power to get the result. Is it? Or you can look at here, they have a same base. This power can be kept in the power of the numerator, if they have same base. If it just here in the denominator, its power is negative, when it go up in the power form, the power will be positive. You can do in that way also. This thing, you know it. Here you have to use the quotient rule of indices. Let us do it. Here what you can write, x to the power, let me do directly, a square. When it go up, it has a minus sign. When it go up, it will have a plus sign. Let me write that over here in between. Plus ab plus b square whole to the power a minus b into, over here also let me do the same process, x to the power b square minus bc is there. When it go up, it will be plus bc plus c square whole to the power b minus c. Let me write this over here down, x to the power c square plus, when it has a minus ac is there in denominator, when it go up, plus ac plus a square whole to the power c minus a. Nothing I have done. This I have divided it. They have the same base and are in division form. Then keep the base same and subtract the power to get the result. Otherwise, let me do, if you have still confusion, let me do for this term. It is the same way I have done for others also. X to the power, look at here, it can be written, this one can be written as x to the power a square plus b square. There's a minus sign. When it go up, it will be power will be subtracted, no? When it go up, means they have the same base and are in division form. Use the quotient rule, keep the base same and subtract the power. Subtract this power minus this power. That will be equals to x to the power a square plus b square minus minus plus ab. This ab I have kept in middle, that only I have done. Don't get confused. Okay, this step you know it. These are the basic things, okay? Now, let me do it. Again, let us see. Now, by the exponent rule or power rule, this index number has a power. If indices has the power, then the power will be multiplied together to get the result or to get the answer according to the power rule of indices. Okay. Now here also we will apply the same rule. X to the power a square plus ab plus b square into a minus b. If power is there together, they will be multiplied together into x to the power b square plus bc plus c square whole to the power b minus c into, over here let me do down, x to the power c square plus ac plus a square whole to the power c minus a, means they will be multiplied together. Power can be multiplied. Now let us see the multiplication in this case. A square plus ab plus b square into a minus b. Now you have learned this formula only. Formula means answer only. Don't get confused. Formula is what? Answer. That means if there is a minus b and a square plus ab plus b square, if you multiply this together, means this sort of form, a minus b, a square plus ab plus b square, it is same thing. Either you write this in front or that in front. What will be the product of this? When you multiply this, it will be equals to a cube minus b cube. Or if you don't know the formula means direct answer, okay? Don't get confused. If you don't know the formula, just multiply it, which you will get the result. You will get the other will be cancelled while multiplying, other will be cancelled. These two terms will only be remaining over there. Means this will be the answer for the product of these two. So you know it, this thing you have learned it. That's what. Now let me do it. What will be the result over here? X to the power a cube minus b cube into, what will be this? X to the power b cube minus c cubes. Similarly over here also, x to the power c square plus ac plus a square into c minus a. What will be the result for this? Cube minus a cube. Okay, this product of this type of number you have learned already in algebraic formulas only. Okay, now look at here, the indices having the same base are in multiplication form. They have the same base x and are in multiplication form. Then what will be the product of this? How you will find it? Keep the base same and add their power to get the result or get the answer. This power plus this power, b cube minus c cube plus c cube minus a cube plus rest. Add the power, plus a cube minus a cube plus c cube minus a cube plus b cube minus b cube equals to x to the power 0. So if any quantity has a power 0, its value will be equals to 1. That's why the result of this type of answer is 1. I think we have copied it. Let us go to next question of simplification, that is okay. Have you done it? Now next question B, next type, it is of next type. Let me tell you, 1 upon this, also simplify it, 1 plus x to the power a minus b plus x to the power c minus b plus 1 upon 1 plus x to the power b minus a plus x to the power c minus a plus 1 upon 1 plus x to the power a minus c plus x to the power b minus c. Okay, this is the next type of question which has came in SE already. Okay, b minus c. Pole is quite small, that's why it is problem there. Okay, let me tell you about this question pattern here. 1 upon 1 plus x to the power a minus b. What is the power over there? In power there is a minus b. A minus b. What is there in minus form? Minus b. Here also, here also. In this fraction, here minus b is kept. Understood? Here three alphabets A, B, C are used. A, B, C are used. In this fraction, in denominator, there is minus b. Minus b means a minus b, and b is in minus form, then c minus b. Here also minus a is there. B minus a, c minus a. Here a minus c is there. Means minus b, minus a, minus c is there. Understood? So don't get confused. Means here, if you practice for 2-3 times perfectly in a proper way, then the question will be memorized. Okay? If question is memorized, then it will be easy for you all. Okay, let me draw it. And let me do it. Now let us go to the solution. Here, you have learned the quotient rule already. Let me tell you one thing over here. Here, x to the power a upon x to the power b means these indices are in division form. Then what will be the result of it? What we have learned it? Keep the base same and subtract their power to get the result. Is it? This thing you know it. We have learned about the laws of indices quotient law in previous class also. So let us follow this rule. It means if x to the power a minus b is there, then this can be written in this quotient form, in fraction, in division form, or they can be expressed in this fraction form. Understood? Okay. Let us apply the same type of rule over here also. Let us do the solution. 1 upon. Now can you tell me 1 as it is? Now a minus b is the means this can be written in this fraction form or in division form? Yes or no? According to the quotient rule of indices, this can be written in this form. Let us write it. X to the power a upon x to the power b. Okay. After that, plus. Here also do the same. It can be written as x to the power c upon x to the power b. I think we can do it. Plus 1 upon. Here also do the same. Let me draw it. This thing you understood. Let me draw this. Okay. One plus x to the power b upon x to the power a. Can you write this in fraction form? Plus here also can you tell it? X to the power c upon x to the power a. Plus similarly over here also numerator as it is 1 plus x to the power a upon x to the power c plus x to the power b upon x to the power c. Now let us carry out the addition in denominator of all three fraction, algebraic fraction. Okay. Now let us carry out the addition. Addition, I think you can do it. These two are the like fraction only in the denominator. So let us do it. What will be the addition of this? Here while adding it, take their LCM. The LCM is x to the power b only. Here also in denominator there is 1, no? So what will be the result over here? 1 divided to x to the power b will be x to the power b. When this is multiplied with 1, that will be x to the power b into 1 means x to the power b only. And then plus. Or you can do in next way. Directly this into this plus this also you can do it. And this, the denominator is same over here. That means x to the power a plus x to the power C 1 upon. This you can do it. Similarly over here also let us do it. In the same manner you can do it 1 whole upon. What will be LCM over here? The LCM will be x to the power a. Now do it x to the power a plus x to the power b plus x to the power c. Is it? Here. Same. Yeah. You can add it. Plus over here also let us do 1 in a numerator part, denominator. But what is the LCM over here? X to the power c. X to the power c plus x to the power a plus x to the power b. I think you don't have any confusion in the addition. You can add it in this manner. Okay. Now let us see. Here in denominator we have one fraction. Fraction is there. So in this fraction there is a denominator. This denominator can be kept, it will be multiplied with the numerator of this algebraic fraction. Is it? It will go up and multiply with 1. Is it? Means 1 into x to the power will be x to the power b whole upon x to the power b plus x to the power a plus x to the power c. Is there any confusion over here? Is there any confusion over here? Or if you have still confusion, let me deal with one algebraic fraction over here only. If 1 is divided by 2 upon 3, then this can be written as 1 divided by 2 upon 3, no? This means 1 is divided by 2 by 3. Can you write this in this form? 1, if you change this division into multiplication form, it will be reciprocal. Means it will be 3 by 2. Is it? Then what will be the result? 2, 3, 1 is 3 upon 2 will be the answer. Here also. That means instead of doing this, what we do now, this 3 denominator will be multiplied by the numerator. The result will be same, no? And this will remain here only. The same process or same rule I have applied over here. No need to show all this process. Okay. Now I think you can do it. Now what will be the result of this? This will go up, x to the power a will go up. Now what will remain? Just arrange this denominator part. Let us arrange it. Means let us write x to the power b first, then x to the power a, then x to the power c. I have arranged it. Just this one will be same over here. I have kept x to the power b first plus x to the power a plus x to the power c. I have kept this denominator also in the same manner. That is nothing I have done. Or you can do in next way also, it doesn't matter. Plus x to the power c will go up and multiply with 1. What will be in this form? X to the power, here also let us write in same form, x to the power b plus x to the power a plus x to the power c. You can arrange in next form also, it doesn't matter, but let us arrange it. If you don't arrange also, it doesn't matter. It means the same. Okay. Now let us do. What will be the LCM of the denominator? Now you can add this fraction again. You have to add this 3 algebraic fraction again. So what is the denominator? Same denominator is there. They are like fraction. That means while adding the like fraction, it is quite easy. Put the denominator over here, x to the power b plus x to the power a plus x to the power c. What will remain over here? X to the power b plus x to the power a plus x to the power c. Now you can see in the numerator and denominator part, you will get the same quantity. Same quantity can be reduced. They will be cancelled. And what will be the required answer? 1. So this type of question is also important with the examination point of view in SEE. Okay. So let me tell you, express these in fraction form first. Express all these in a fraction form. Add the denominators. And you will get again 3 algebraic fraction, and add those algebraic fraction, you will get same numerator and denominator, cancel them, that will be a 1. This is also important question. Or you can do this question by next way also. Okay, you can do this question by next way also. There are 2-3 ways of doing this, but I find this quite easy. That's why better you follow this process. Okay, you better follow this process. Or you can multiply with the minus b over here. Here multiply numerator and denominator by minus a. Here by minus c also. If you do in that way also, you will get it. Here the condition will be given in next. This if a plus b plus c equals to 0, then yes, I M P L I F Y simplify. Yes, 1 upon 1 plus x to the power a plus x to the power minus b plus 1 upon 1 plus x to the power b plus x to the power minus c plus 1 upon, can you guess what will be the next term over here? 1 plus x to the power c plus x to the power minus a. Simplify this. Or sometimes you may be asked, if a plus b plus c equals to 0, then prove that this equals to 1. Maybe that question also may be given in that way, but the process of doing this problem is same. Okay, now for doing this problem also there are 2-3 ways, but I'll tell you quite easy way of doing this problem. Now equals solution, write the solution. If there is a fraction, then you can multiply by any number in numerator and denominator part to get the equivalent fraction. Just if you multiply by 5 and 5 in denominator part, what will be? 2 5s are 10, 5 3s are 15. Means this 2 by 3 will be the equivalent fraction of 10 by 5. Means to get the equivalent fraction, you can multiply the numerator and denominator by the same quantity. Means it doesn't make any difference. Means if you reduce it, you'll get 2 by 3 only. Yeah? Here also what we do in this problem, here in this, look at the first fraction. Here also we multiply the numerator and denominator by the same quantity, so that we can get any two fraction is the like fraction. That means here also in this fraction we will multiply the numerator and denominator by the same quantity. So by what we have to multiply, that also you should know it. So here by what we will multiply over here, by what we have to multiply. Here look at the negative part, x to the power minus b is there. We have, if there is minus b, then with its positive power of the same, means we have to multiply numerator and denominator of this by x to the power b only, x to the power b, so that we can get the denominator of two quantity is the same. That means two fraction will be converted into the like fraction. Let us write 1 plus x to the power a plus x to the power minus b is there. Multiply this numerator and denominator. Numerator is 1 by how much? X to the power b. X to the power b. Other keep as it is. One other keep as it is. 1 plus x to the power b plus x to the power minus c plus 1 upon 1 plus x to the power c plus x to the power minus a. Other I have done nothing, just I have kept as it is. Okay, now what will be this? X to the power b, no doubt. Now multiply it. X to the power b, this b, x to the power minus b should multiply to all the terms of this denominator. X to the power b into 1, that will be x to the power b, plus x to the power b into x to the power a. Means when they are multiplied, they will have a same base. Keep the base same and add the power to get the result. A plus b or b plus a, it is same thing. Plus x to the power b into x to the power minus b. Again they will have a same base and are in product form. Then keep the base same and add the power while adding. Plus b minus b will be cancelled. That will be equals to x to the power 0. That will be equals to 1. Let me write it directly. I think you will understand this thing. Plus Let us do it. Other as it is 1 plus x to the power b plus x to the power minus c plus 1 upon, here also the same, 1 plus x to the power c plus x to the power minus a. Other I have kept same. Okay, don't get confused. Okay, now let us see here. A plus b, we have to replace this. A plus b equals how much? From this given condition, a plus b equals to how much? Let us replace it. Let us see. From given condition, you know it. A plus b plus c equals to 0 is there. Then a plus b will be equals to how much? From this given condition, this since, okay, 3 dots means since a plus b plus c equals to 0, then what will be a plus b? A plus b will be equals to how much? Take the c to that side. 0 minus c will be minus c only. Therefore, a plus c will be equals to how much? Minus c. So, now let us replace this a plus b by minus c. Can you replace it? Yeah? For that only given condition is there. No? From here only a plus b can be equals to minus c. Let us do it. Let me do from here. Okay. X to the power b whole upon x to the power b plus x to the power minus c. Can I write it? A plus b equals minus c plus 1 as it is. Plus here also 1 upon 1 plus x to the power b plus x to the power minus c. Can't you see? See? Can you see? These two denominators are same. Means here these two fraction has been converted into the like fraction. Okay. Now next one also write as it is. 1 upon 1 plus x to the power c plus x to the power minus a. Okay, now let's add this. You know, if they are like fraction, it will be quite easy for you to add. That will be x to the power b plus x to the power minus c plus 1. This is same, no? They are written in zigzag way, but the result will be same, no? Don't get confused. X to the power b is there, plus x to the power c is there, plus 1 is there. Okay, now what will be the addition of these two? I am adding these two only. X to the power b plus 1 plus. Now let us see this. 1 plus x to the power c plus x to the power minus a is there, no? Now, here also, let us try to make this two fraction as a like fraction. Means, let us have the same denominator what is here over here also. For that, what you have here also, for that you have to multiply its numerator and denominator by the same quantity. You can multiply the numerator and denominator of this fraction also by the same quantity. By how much you have to multiply so that the denominator will be same. So for that, now look at here. What is there in negative part over here in this fraction? There is x to the power minus c. So with that only multiply the numerator and denominator so that their denominators will come same. Okay. Now let us write x to the power minus c. 1 is there already. X to the power minus c. Can you do it? Have you understood or not? By what we have to multiply its numerator and denominator? By this quantity. In a denominator you can say it. Minus c is there. X to the power, what is there in denominator in this fraction? In which have a power minus? This one. So with this multiply its numerator and denominator. Now let us do it. What will be the result? X to the power b plus 1 upon x to the power b plus x to the power minus c plus 1 as it is. Here, let us do it. X to the power c into 1 x to the power c only. Now, multiply this with this also, this with this, and this with this. X to the power c into 1, x to the power minus c into 1, x to the power minus c. Plus x to the power minus c into x to the power c. They have a same base, they will have a same base. When they are in multiplication form, add their power. Well, adding their power, c minus c will be there, x to the power 0, that will be equals to 1. Let me write it directly. Plus x to the power, let me write this, x to the power minus a minus c. I think you don't have any confusion in this. X to the power c into x to the power minus a. While doing it, they have the same base, keep the base same and add the power. While adding the power, minus a minus c. This thing you can get it. Okay, let me follow the next step. May I rub it? Okay, let me rub this. Okay. Now, just now you have to make the denominator same by replacing this minus a minus c. All are same, no? X to the power minus c is there, 1 is also there. Now x to the power b should be there, no? So we have to replace this power by b. Okay, then they will have the same denominator. Okay, let us do it. Now before knowing that, let me tell you one thing. Here minus a minus c is there. From the given condition, minus a minus c will be how much? Let us find it. Yes, since these three dots means since a plus b plus c equals to 0 is there. Is it? Now can you tell me, keep this b in this side and other in that side. B in this side, other in that side. A and c in that side. A has a plus sign, when it go in that side it will be minus a. When c also has a plus sign, when it go in that side that will be minus c. Therefore b will be equals to how much? Minus a minus c. In place of minus a minus c, can you replace b? Can you put b? Yes. Let's do it. Over here let us replace this minus a minus c by b. Other as it is. Let us do it. 1 upon x to the power b plus x to the power minus c plus 1. Sorry, numerator what is there? X to the power b plus 1 plus what is there? X to the power c is already, sorry, x to the power minus c is already there, no? C is x, this is x to the power minus c. X to the power minus c whole upon x to the power minus c plus 1 plus this x to the power minus a minus c equals to how much? B. X to the power b, you can write it because from this condition minus a minus c equals to x to the power b. Now let us write what will be the required form over here. Now they are the like fraction. They have the same denominator, x to the power b, x to the power b, x to the power minus c, x to the power minus c plus 1. Now let us do it. What would the LCM of these two? Same, x to the power b plus x to the power minus c plus 1 will be the LCM. Now what is the numerator part? X to the power b plus 1 plus x to the power minus c. Now let us rearrange it, this numerator part. You can arrange it, x to the power b plus x to the power minus c plus 1. Can you rearrange this? If you, result will be same. So here also x to the power b plus x to the power minus c plus 1. Now here also you get the numerator and denominator, same denominator and numerator will be there. Now they can be reduced, or means they can be cancelled. That will be equals to 1. So this is also very important question with the examination point of view. Okay. Now we will go to next type question. Okay. Next type of question, it is similar to this only. And here, don't get confused. In place of A, B, C, there may be P, Q, R, and here P minus Q, Q minus R, and so on. Alphabet may be different, but the alphabet may be different. It will be of same pattern only. Question will be of same pattern. To apply the same process for this type of question. Okay, now let me go to next type question, that is D type question. Okay, simplify only. Okay, simplify only. Okay. Here, the question, this is C, now D type question. Let me do D number question. If x, y, z equals to 1, then simplify, or in place of simplify, then maybe prove that also. It doesn't make any sense. It is same. Okay. Okay. What will be this? 1 upon 1 plus x plus y to the power minus 1, or y inverse, or what? Y inverse plus 1 upon 1 plus y plus z inverse, or z to the power minus 1, plus 1 upon 1 plus z plus z and x to the power minus 1, or x inverse. If proof is there, this equals to 1 will be given to you. Don't get confused, okay? Now, I think you understand the question. If x plus y plus z equals to 1, then you have to simplify this, or prove that this equals to 1 may be given to you. But the process will be same. So, here let us start with the solution. Here also your target should be making their denominator like, make their all these three algebraic fraction is a like fraction. But how to do? Yeah, what are the steps to be followed? That thing I am going to tell you. Okay. Now solution. Here, how you can make it better? What you can do by any other ways also. Here, what I think is, x is there. Let us replace this x and x inverse, this two, in term of yz, in term of what yz from the given condition. Means keep all this denominator in term of yz only. Yz where there is, here is yz only, no need to replace. Here is x inverse, replace x inverse in term of yz, this x also in term of yz. Okay, then it will be, then there is a chances or probability of getting the same denominators. Means you will get the like fractions. Okay, now let us see. For that, let us see the given condition, how we can replace it. X, y, z equals to 1, you know it. Now x will be equals to how much? Implies x will be equals to how much? Y, z are in multiplication form over here with x. When it go to that side, they will go in division form. Okay. Now x can be written as 1 upon yz. So x can be written as what? 1 upon yz. No doubt. So let us see here also. X inverse will be written by how much? For that, let us see. Here. This implies over here x, y, z equals to 1. So y, z keep in this side only. What will be x when it go to that side? It will go in division form. That's it. This can be written as, that means this implies what? Yz equals to x by the negative rule of indices. If it has a index, when it is taken to numerator part, its power will be negative. It has a power plus 1, no? When you go up, it will be x to the power minus 1. So x inverse means x to the power minus 1 will be equals to yz. Can you write this x to the power minus 1 equals to yz? Here you replace x to the power minus 1 is yz, and here x is the 1 upon yz. Then let us see what happens. What will happen? You will get a like fraction, like algebraic fractions. Then it will be easy to add. Then you will get the required solution also. Okay, now let us do it. 1 upon, let us go to the solution. This thing is given condition. Okay, this is what? Here, this is there. Okay, so while doing the solution, better you write this question only. write this question, okay, and then start the solution. But here, due to the lack of space only, I am just keeping one step. I am not writing this question. I am starting from next step, okay? Okay, 1 plus x equals to how much? Replace this, I told you, 1 upon yz plus y inverse. Write this also in fraction form by negative law of indices. It can be written as y 1 upon y to the power 1 means y only plus. Let us do this. 1 upon, no need to do it, 1 plus y plus 1 upon z by root negative law of indices, okay, plus. I think let us do it. 1 upon 1 plus z, I told you the same, plus what x inverse should be written as yz. Is there any confusion to anyone? Just I have replaced x and x inverse in term of yz from the given condition. Okay? Okay, let us do it. Now add the denominators. Denominators, can you add them? Okay, you can add it. 1 upon, what will be the LCM of these three denominators? Yz. Now what will be the answer of this? 1 into yz, you can do directly yz plus 1 plus y will be removed, z into 1z plus. Now do for this also. What will be the LCM of this? Z only. In a denominator there is 1 1, no? Here also denominator 1, here also 1. You know it. Now LCM will be z. Now carry out the addition. Addition, you know it. I think I don't have to tell you again and again this process. This thing you have learned in previous class. Plus over here also. I think, do you have to do here? No, it is already arranged. No need to do for this. There is no need of addition. There are the unlike terms in the denominator. No need to do. Okay. Keep as it is. This one, keep as it is. Okay. Now let us do it. Okay, I have told you in previous question also, this, if there is a denominator in denominator there is a fraction, and this denominator of lower part will be multiplied with the numerator part, means upper part of this whole fraction. Okay, now this will go multiplied with 1, that will be equals to yz. 1 into yz will be yz. Let us arrange it and write it. It will be quite easy. Yz plus z plus 1. I have arranged it, nothing I have done. This as it is. Plus, let me write this also. Here it will go up and multiply with 1, that will be z into 1 will be z. Yz, let us arrange it. Yz, let us write this first and then z. And lastly, let us write 1. You can arrange it next way also. It doesn't mean that you have to arrange in this way only. I have yz plus z plus 1 plus. Let us arrange this also. Yz right in front, it doesn't matter, plus z secondly, and lastly let us write 1. And now this has been reduced into the like fraction. These are the like fractions or not? They have the same denominator. Now you know how to add this like fraction. That is the easy way. There is an easy way of adding them. Let us add it. Let me draw from here. I think you have noted it. Now they have a like fraction. Well, now let us add these three fractions together. Now take the LCM. What is the LCM? If they are like fraction, they have a same denominators. So what will be the LCM? Yz plus z plus 1. LCM will be same. Yes or no? This is LCM. Now what will be over here? Yz plus z plus 1. Now here also you will get the same numerator and denominator. Yeah, denominator is also yz plus z plus 1. Numerator also will come yz plus z plus 1. The same quantity is there. Reduce it. What will be the required answer? 1. When same is divided by same, the result will be 1. Hence, this is the required answer. So this question is also important. Okay, so here the more you practice, the more you learn. So practice makes the man perfect. So practice it perfectly. Practice it perfectly. Okay, now let us go to next type of question of this indices. Okay, there of it. I think let once copy it. Okay, now let us go to next type of question. Okay, D E number. Now here also you will be asked to simplify these indices. Okay, now let us see the question. X square plus 1 upon x square, sorry. Okay, x square minus 1 upon y square whole upon p, see here, okay, into x minus 1 upon y p minus q. Sorry. E. That means x square minus 1 upon y square whole to the power p. Okay, and into x minus 1 upon y whole to the power q minus p whole upon y square minus 1 upon x square. Here p is there and q whole into y plus 1 upon x, here p minus q. Nothing is there. We have to use the rules of indices and simplify it. So, okay. Now, look at here, in this numerator part, look at this. It is in the form of a square minus b square form. Is it? Means this numerator part can be written like this: x whole square minus 1 upon y whole square. That, yeah, and whole square is already there, no? So it is in the form of a square minus b square. Means it can be written as a plus b in one bracket, a minus b in another bracket. That is factor formula for a square minus b square. So a square minus b square, what is the factor formula for this? A plus b in one bracket, a minus b in another bracket. Is it? This you know it. The same formula you have to apply for this. Let us do it. Okay, let me log it. That is equals to, let me give a big bracket over here, here also, and here also it is also in the form of a square minus b square. Use the formula for a square minus b square. Use the factor formula for a square minus b square. Now let us do it here. X plus 1 upon y, x minus 1 upon y whole to the power p, and this one keep as it is, x minus 1 upon y whole to the power q minus p. This one keep as it is. Okay, here just I have used the factor formula for a square minus b square for these two expressions which are in bracket. Okay, means where a is x and b is 1 upon y. Okay, this is a factor. Here also let us do the same. Use the factor formula of a square minus b square. It is in the form of a square minus b square. So use that factor formula for this a square minus b square. Now what will be this? I think you can do it y plus 1 upon x whole to the power, or let me do one step, into y minus 1 upon x whole to the power, or whole to the power q. And this next keep as it is, as it is. Okay, now I have done nothing over here, just I have applied the factor formula for a square minus b square, because these two expressions are in the power of a square minus b square. Another part I have kept as it is. Now let us write this x plus 1 upon this whole p, means this p is for this also, this power is for this, and this, let us separate it. X plus 1 upon y whole to the power p, it is a power for this also, x minus 1 upon y to the power p, yeah, it is a power for this also. Next one keep as it is, q minus p. Here also the same process, y plus 1 upon x whole to the power q, y minus 1 upon x whole to the power q, and this also y plus 1 upon x whole to the power p minus q. Up to here I think you have understood. So I have told you in previous question, or in previous questions also, after writing the solution, better write the question and start doing it. But here you may arise the question, why you haven't done? You may ask in that way, because I have told you, I have clarified you that there is a lack of space over here. That's why. So I have skipped one step, means I haven't written the question. Okay, now let me proceed it. Now let us see here. Can you see these two have a same base? X minus 1 upon y, x minus 1 upon y. They have a same base. Yeah? And are in multiplication form. Then to get the result, keep the base same and add their power to get the result. Here also, these two have a same base and are in multiplication form. Keep the base same and add their power, these two power, to get the result. And others, this one keep as it is in the upper numerator. This keep as it is. Let us write x plus 1 upon y, keep as it is. Now carry out the multiplication of these two indices. Keep the base same, 1 upon y, and add their power, p plus q minus p. Here also the same process. Which one? This one keep as it is, because these indices do not have the same base. This base is not there in denominator part. Y minus 1 upon x whole to the power q as it is. And while multiplying these two indices of the same base, what will be the product? Keep the base same. This base is this, and add their power, q plus p minus q. Okay, now let us do it. What will be the result? This is minus p and plus p will be cancelled, minus q plus q will be cancelled. What will remain? X. Sorry, where is p? P has gone. Okay. So here x plus 1 upon y whole to the power p, this y minus 1 upon x whole power q, and this is there. Now better what we do, let us do one step. I'll skip it. I want to skip one step, or let me do this step only. X plus 1 upon y whole to the power p is remain out from here. X minus 1 upon y whole to the power q is remain in numerator part. In denominator, y minus 1 upon x q on y plus 1 upon x whole to the power p is remain. Now carry out the addition of these brackets. Carry out the addition. Okay. Let me draw it. Let me draw from here only. What will be the addition of this? What will be the denominator of this? 1 is there. Add this. LCM will be y. Now, okay. What will be the LCM of this? Y. Now let us y into x, yx, xy plus 1 whole to the power p. Is it? I have added this only, power p as it is. Here also let us do it. Xy minus 1 upon y whole to the power q is there. Let us do for denominator. Y minus, oh, sorry. Now what will, let us do same for the denominator. Let us subtract it. What will the LCM? X is the LCM, and xy minus 1 whole to the power q is there. Here also let us do it. Xy plus 1 whole to the power x, sorry, upon x, xy plus 1 upon x to the power p. I think up to here, I think you don't have any confusion. Nothing I have done. I have added the quantity which are there in bracket. Understood? And other I have kept same. Okay. Let me proceed the next step. Now, this whole to the power p means this power p is for this also, for denominator y also, q is for this also, y to the power q. So let us separate them. Okay. So power p is for both numerator and denominator, no? So let us separate it. It will be easy for you. Okay, let me write it down below. Okay. This means x plus 1 x, sorry, let me write xy plus 1 whole to the power p whole upon y to the power p. Over here also xy minus 1 whole to the power q upon y to the power q. Is there any confusion? There is a multiplication sign. You understand it? Here also below also xy minus 1 to the power q whole upon x to the power q into xy plus 1 to the power p whole upon x to the power p. Means this whole power means it is power, just it is a power for both the quantity, numerator and denominator part. Here also the same. Okay, just I have separated. Nothing I have done. Is it? Okay. Why I have separated? So that we can get the same base indices, and we can use the rules of indices, laws of indices for simplifying them. Yeah, that is only the case. Okay, there was no other way. Now let us see. It is in denominator part. These two are in denominator part. When they go up, it will go in numerator part. You know it. Is it? It will go in which part? In numerator part. It will be multiplied with the numerator part, and this will come down and will be multiplied with the numerator of the lower fraction. Okay, lower quantity fraction. You know it. Now what will be that? Let me tell you. Xy plus 1 whole to the power p into x to the power q into xy minus 1 whole to the power q into x to the power p whole upon y to the power p into, it will come down, it will be multiplied with this xy minus 1 to the power q into y to the power q into xy plus 1 to the power p. Okay, one step I have jumped here. Okay, I think you don't have any problem in this. Now let us say this two quantity has the same base. Can you see it? Xy plus 1, xy plus 1. That's it? They have the same base and are in division form. That's it? Division up. This is there, down it is there, means lower part it is there, means they are kept in fraction form but it is in division form. Now use a quotient rule. What the quotient rule tells? keep the base same and subtract their power to get the result. Let us do it. Xy plus 1, they have a same base. Let us do the division of this indices. P minus P will be the required answer for this two. Okay, now into, let us do for these two also. Look at these two. Let us divide these two first. They have a same base. They have what? Same base and are in division form. Then keep their base same. Sorry. Keep their base same and subtract their power to get the result. Okay. So xy minus 1 whole to the power q is there. When divided, minus q will be there, means they have the same base, subtract the power, q minus q. Now let us do for these two. They have a same base and are in multiplication form. Then keep the base same and add their power to get the result. Means multiplication of these two also has been done. Now denominator also carry out the same process. Do the same process here. These two have a same base and are in multiplication form. Then keep the base same and add their power to get the result, to find the product of these two. And this has been already done. Divided. Okay. Now xy plus 1, let me do this step also, it doesn't matter. Xy plus 1 whole to the power 0, is it? Into xy minus 1 whole to the power 0 into, let us say this, x to the power q plus p can be written as p plus q. Can you write it? And let us write this over here, it doesn't matter, it is same thing. Y to the power p plus q. I think you don't have any confusion over here. Now let me tell you, if any quantity has a power 0, then its value will be equals to 1. We have learned that rule already in laws of indices. Okay, if x to the power 0 is there, that will be equals to 1. Don't get confused. Similarly, look at here, if x to the power 5 is there, next way I'm telling you, if and y to the power 5 is there, means if the indices has the same base and are in if they have a same power, that's it, x to the power 5 is there, y to the power 5 is there, then this can be written as xy whole to the power 5, is it? This means if they have the same power, then this can be written as whole power of this number 5. This here also the same process, this process I'll apply. Here this will be 1. If any quantity has a power 0, that's value will be equals to 1. This will be 1 into, look at here, they have a same power. Can it be written as a whole power of this x upon y? It can be written as x y whole to the power p plus q. This means this power is for this also, this power is for this also. Is it? This can be written in this form, that will be equals to x by y whole to the power p plus q. So this is a required answer or required solution for the indices. This is a simple form of the problem. So this is simplify. Okay, simplify means reduce by using a different algebraic operations. Okay, this is also very important question. Okay students, let us go to the next type of question. So here in next type of question maybe like this. Okay, if conditional question is this, if x equals to 3 to the power 1 upon 3 plus 3 to the power 2 upon 3, then prove that, or show that also it may be, prove that x cube minus 12x minus 9x x cube, then prove that x cube minus 9x minus 12 equals to 0. Okay, if this x equals to this much, then you have to prove this. So let us start the solution. Okay. From this condition we have to bring this. Means here you can do this by two ways only, two, three ways. Here what you do, let me tell you a easy way, so that it will be easy for you also. So what you do, you better start to do from the given condition. From given condition. Let me write what is given over here. What is given? X equals to 3 to the power 1 upon 3 plus 3 to the power 2 upon 3. To prove x cubed minus 9x minus 12 equals to 0. Now, from where we have to start? To prove this, start from the given condition. It will be quite easy for you. X equals to 3 1 upon 3 plus x 3 to the power 2 upon 3. Let us start from this. Now from this we have to show this, means we have to prove this, means we have to bring x cube. But how x cube come from here? There is no chance unless you cube this. Unless you cube it, there is no chances of coming x cube. So what you do in first step, if you cube in this side, then you will get cube x cube. If you cube here, in that side also you have to cube it. Means that is a rule of equation, no? So what you have to do in first step, cubing both sides of equation, we get what we get, x whole cube equals to 3 1 upon 3 plus 3 2 upon 3 whole to the power cube. Can you cube in both sides of equation? Why we have to cube? Because we need a x cube, so we have to cube in this side. If we cube in this side, that side also it should be cubed. Yes or no? That is a rule of equation. Okay, now let us simplify in both sides of equation. Or x cube equals to, now it is in the form of a plus b whole cube. A is 3 to the power 1 upon 3, b is 3 to the power 2 upon 3. Now we have learned already. What we have learned? The formula for a cube, since a plus b whole cube, what is the formula for this? A cube plus b cube plus 3ab a plus b. This formula you know it. A plus b whole cube. What is the formula? Formula means it is an answer. Don't get confused. So a plus b whole cube will be equals to a cube plus b cube plus 3ab, again bracket a plus b. So here also it is in the form of a plus b whole cube. A is this one, 3 to the power 1 upon 3. B is 3 to the power 2 upon 3. Let us apply the formula and expand it. A cube means 3 1 upon 3 whole cube. Let me do first. Plus b cube, 3 to the power 2 upon 3 whole to the power cube, means whole to the power 3, plus 3ab. What is a? 3 to the power 1 upon 3, 3 to the power 2 upon 3, 3ab. Again in bracket what you have to write? A plus b. A is what? 3 1 upon 3 plus 3 2 upon 3. A plus b means what is a? This one. B is this one. No. Let me do it. Or, you know this formula. Let me drop this. Let me do one down. Now what will be this? Now let us do it. Or x cube as it is equals to, now this power has a power, means power will be multiplied, so that they will be cancelled. Here also this will be cancelled. That will be equals to 3 to the power 1 means 3 plus 3 to the power 2 means, let me write it, that is 9 only, plus. Now these are the indices having the same base and are in multiplication form. Keep the base same and add their power to get the result. 1 upon 3 plus 2 upon 3. And now this equals to how much? 3, 1 upon 3 plus 3, 2 to the power 3 equal to x. This equals to how much? X. So can you replace this by x? Now let us keep it. X. That is equals to x cubed equals to 3 plus 3 square means 9 plus 3 to the power how much? Now add them. How much? 3 to the power 3 means 1. Can you do it? 2 x. It will be, when you add it, it will be 2. Means it will be 6 upon 3, that is equals to 2. I have done directly, don't get confused. Okay, x cubed equals to how much? 9, 10, 11, 12 plus 9x. Now replace all these to this side. In left hand side, what will get it? X cubed, it has a plus sign. When it comes to this side, it will be minus. It has a plus sign. Bring 9x, minus 9x, minus 12 equals to 0. Hence, proved. So you can prove in this manner, okay? Or you can do by next way also. You can take the left hand side, replace the value of x by this and get the result. Okay? You can do by next way. Let me tell you again. You can take this left hand side, replace x by this value, keep on solving left hand side, you will get 0. That is also next way. So better you do in this manner. What you have to do, take the given condition, you both the side, replace all this right hand side to the left hand side. After simplifying, then you will get the required answer, required condition that should be proved. Okay, thank you class. So these are most important, and there is a next part from this chapter, that is exponential equation. Exponential exponential equation. Exponential equation is there, but it is quite easy part. So practice this question properly. So next part is their exponential equation. I think it is quite easy part.